All righty. This is Durwood King and our MNT 110 class. This is November 12th, 2020, and this is our last regular class day for the semester. And we're going to wrap it up today with doing shaft and coupling alignment using conventional straight edge and feeler gauge method and dial indicator. And if we can get time in, we'll take a look at the laser. But we'll start out with the most easiest, cheapest, most readily available form would be straight edge and feeler gauge. You can do that when you don't have anything special, and you can still get it very, very close, pretty good and acceptable. So they're in the background doing a fine-tune adjustment there. And basically what they've done is this is a rigid coupling here. And you don't always have a rigid coupling. There's cases where you're going to have an elastomeric element in there.
That box right there, that's
dial indicator. You put them up? Well, I don't remember putting them up. Maybe I did. But I tell you, I don't remember putting them up, though. I swear I don't. I'm not going to go. Yeah, I thought I was listening.
oh.
What would be typical would be the spider type coupling like that. That's what's really, really common. And you may see the grid couplings also. So you're not always going to see a rigid coupling like what you're seeing here. So this presents the most challenge of any of them because there's nothing there that can, there's no flex at all in there. So this is going to be the hardest one to ever line. So basically, in a nutshell, what they're doing is they're taking something that's absolute straight edge, that's perfectly straight. That's a piece of carbide. That's a carbide coated from a blade. You can find anything that's perfectly straight. You lay it right across that and put a flashlight behind it. And if you see any daylight behind that, then that's the indication that you need to put a shim, under. You need to possibly shim the motor up. And one thing that I didn't emphasize, that the book does emphasize, is this: in the very, very beginning, before you start any of this process, before you even examine for soft foot or any of that stuff, you need to make sure that the motor is actually sitting lower than the driven machine. Now, the reason for that is if you start out in the beginning, and let's say this is a pump. Let's bring this out here. We've got a dummy load here with no real function to it other than it's just being driven. It's got pillar block bearings on there. But let's say it's a pump and you got piping coming in. You've got two pipes, the suction line, discharge line. And once it's plumbed in, of course, you can't move that pump, right? You can't move it, you're going to upset something. So let's say you got a pump, it's already plumbed in, and you have a motor, and in the beginning with no shims in there whatsoever, you find out that the motor is already a little bit higher than the pump. Now, does that sound like that could be a real problem? And why would it be a real problem in the beginning? You can't, because you can't move the pump up. You can't, exactly. That's the whole key. They mention that in the book. It's in that chapter. So you need to make sure that if the pump is not a little higher than that, you need to go ahead and get it boosted up somehow and make the adjustments on piping so it's a little bit higher than that. Unless it already happens to be dead on level, which it's probably not going to be. But if it's higher at all than that, then you got to back up and, and redo it. You got to get this up some, because you can't go down with the motor at this point. So that's one that they do bring up, and I won't try to point out where it is, but it's just in that chapter. So then they're doing their straight edge and feeder gauge method. So if there's whatever gap is in there, they're trying to find what thickness it is by the number stamped on the shim, and then they're going to add to the base, to the feet, to get it lined up with that. So you do it up here at 12 o'clock. You can also do it at 9 o'clock, and you want to hold that. So right now we've got a problem. Let me use a dim light to see. Let's put it on low. So you can see there that gap behind there. And let's move it in. Yeah, you can see the gap in there. So you've got some horizontal misalignment there, some parallel misalignment that we've got to correct. So where that light is in there, they're going to put the feeder gauge in and figure out how far to move it. And so this is going to be if you think about it really good here, since it's sitting at 9 o'clock, we're not going to do it. Are we going to do it with shims or what? No, you don't need shims for this. But we're going to use these jack bolts. So these jack bolts will, on each side, you got 2 on this side, and let's shoot it on that side, and you got 2 on that side. It's going to let you move that motor plate this way, east and west, horizontal, evenly. And if you count the number of flats that you move, if you turn it, say, 3 flats, and count 3 flats on that one, you can move it evenly and not have it crooked or not have it skewed. So he's doing that, and we're
not going to move that. It's 0.025.
0.025? Yes.
That's for the little drag.
Where are you pushing? Are you pushing on this side, or are you pushing? Because it looks like more than that, though.
There you go.
Mm-hmm. Let's see that. You've already moved it.
Yes, sir.
You've already moved it. Yeah. I was getting to say, yeah. Yeah, exactly. So they've already moved it. So see what it is. I'm 57. I'm 57 years old, and this old brain still works fine, but it's a little slow unless I've had a plate of fish. And then it speeds up, but then it don't last long until I get some more fish. I'm just gonna tell you that. So that's kind of the problem, is I ain't had no fish yet. Right now, So it's Thursday. Yeah. Look at me out there in YouTube land. See, each Friday, if I don't get the fish, these wheels they'll start squawking like, and it's almost happening now. We got to do something about that.
I don't like fish.
You don't like fish?
I don't eat fish.
It's gonna make my mind work better.
So let's go right here and let's look at the precision job that these guys have done here. I want you to look at that. Let's get the. Look at that right there. Straight. You see, you can barely see anything in there now. Do the that shim that you're talking about, the feeder gauge, and there's a little bit of drag on that. Now, for our YouTube audience, let's show the number on there. And let's actually do a focus here so they can read it. So this is going to be some proof in the pudding here. Right, so it's .0025, so it's .0025, which would be 0.06 millimeters, which is actually it's like 25/10,000ths of an inch. 0.0025 is 25/10,000ths of an inch, which is extremely small. So you're very good. You're less than that 5,000th we would shoot for, like a general figure. And then go back up top and see what we have here. I feel a little bit of something there, but it's not much. And so here, let's get our camera back around. If the 5 didn't go in there, then and I tell you, I don't see, that's looking extremely good right there. Extremely good. Extremely good. Okay, so at this point, we can compare it and see what the dial indicator says. We can see how it talks to us now. That was 2. So, okay, so I'd say you're good. No, that's fine. If you wanted to go smaller, you could, but you're fine with that amount right there. It's extremely close when I don't see no light up under there. You see any light under there? I don't see any. The only thing I see is where the crack is. And there's a little bit of a radius on the edge here, and there has to be. That's all that is. And that don't count. So they call this a rough end alignment in our chapter, a rough end alignment. Doing it this method. In some places they don't have dial indicators or lasers, so this is fine. And you don't have all that. And most places, well, a lot of places are going to be like that. So next would be, we can clamp the dial indicator on and just see what it says. And there's different kinds of jigs on there, and it's ideal if you can clamp this jig on the movable end and then let it shoot a number off of here, but there's not room to clamp it in there, plus tighten the bolt. So we got to clamp it on this end and shoot this end and read it in reverse, because there's not room to put the mounting in there. The shaft is so short on the motor end of it. So there's a lot of varieties on clamping devices to get a dial in there. We're going to clamp here and get a reading off of these. We're also making sure that we're leaving. It's already tight there. Yeah, if you can loosen those, loosen them a little bit, we'll get a reading off of it every time with this. Once it's tight, it's not going to last. There's
We got one. Yeah, you do. There's 11. That's what I use. That's all I have. All right. Look.
We got start with these males together, so you want to show that you move the ball, let it show up. Once you clamp, you want to see it. Feel a little bit of it. So let's see. Don't wrap this around like that. Just gonna go to that and then you can turn the back this here off. It didn't clamp it up. See my that right there? You shooting off of this rim in the center of it. And you want to be, let's talk about the plunger stroke. This plunger, you want to be in mid-stroke on the plunger, not at the end and not all the way in. And you want the plunger to be shooting off of this rim right here.
That's their
Mm-hmm. And you want to position it so that you're in the middle of the stroke, so it can actually float and give you the real number. Otherwise, it can run out of stroke either way, and then you're not going to be getting accurate reading. And you got to tighten everything up super tight, and then you also have a little thumb lock right there. Make sure all that's nice and tight there too. Now you want to put it at 12 o'clock and put it on 0. So let's get the so yeah, tweak it a little bit more, or am I looking at it wrong?
-1.
It goes straight on to 12. Okay, it's off a little bit. So you're at 12 o'clock right now. Now bring it real slow down to 3 o'clock, and let's see what we got. So 3 o'clock.
15.
Get the bag glare. Oh, let's cut this a little wide. So you got 15 there, and now go all the way down to 6 o'clock. Let it go to 6 o'clock.
Eight.
So it's actually better down there. And then you come on back up top again. Well, actually, get down here at 9 o'clock. You're sitting here at a minus 5. That's a -5, and that go over to 3 o'clock.
Looks like 12. 12.
You've got a plus
13.
a plus 13.
Almost 14.
So if you zero it now, at the most extreme number, and now bring it back to 9 o'clock, then it's going to give you the TIR, your total indicator reading, which would be
-20.
17. It's a total of 17. So what that means is it's 17 thousandths when you read from it's a plus 17. It's a plus 17. Mm-hmm. Which means that from there to there, it pushed in that far. If you just take a look at your horizontal reading for right now, just take it on back down to the. So you're sitting at the, what was it, 0 here? You're at 0 there. You're at 0 right there. And think about where we're reading it from. We're reading it from the stationary machine. And if you come on around now to 9 o'clock, and you're getting a positive 17 right there.
That's negative.
Or it's negative. It's negative. I'm sorry. It is negative. I'm glad you said that. My brain is all twisted around here. So it's a negative 17. Negative 17, which means which way do we need to move what? Which way do we need to move the motor? Because something's actually moved. Something moves when it got loosened up. Something moved. Is all that tight? Is all that down there tight?
Mm-hmm.
Oh, it's all tight. Okay, so by this being stationary right here, and if this is saying a negative 17, then it needs to move that way. Yeah. And you can feel it with your finger right. You feel that little lip there. Mm-hmm. So what you could do, you could actually leave the dial on there and do the adjustment and just tweak it with the jig on there. Mm-hmm. You can try that. See if you can get that.
Gas straight on the other one.
That's another thing. We didn't even check run out, did we? Did we check run out? We didn't even check run out, did we? So that's another issue. We can verify that by.
That's straight. The shaft is straight.
Yeah, let's leave that jig where it's at. Let's just get a regular dial and let's actually spin it and check run out of these individual ones and see do we have a floating deal going on here, okay? Because we did not do that in the beginning, did we? We didn't. So that's all we have to do. If you can grab the that dial out of there, I think where is it in here? It's actually right here, Patrick. I'm sorry. Yeah. So here, we got to go somewhere nice and solid. Okay. That's going to be too far away. We got to go close enough to be able to get a radio reading, a radio run out reading off B20. You can actually do it. You can actually do it. Hey, you can actually do it. Dr. Valenti, Evelyn. No. Evelyn, the van driver out there, South Station. It's just a consultation. It's a consultation about getting that port put in, having that port put in. The port, he's not going to put it in today, but he'll talk to you about it, and then go another day to get it put in for the treatment. Yeah, but she'll take. I can't go to that class. So you'll have to. She'll take it, and I'll find out. Let me know what you can do.
This one, so the boat.
But if you do, and I'll talk to you after a while. Bye bye.
I'm gonna take that over.
Right. And that's fine. You can do that. You can unclamp that. That's not a problem. Sort of what a couple of ways you want to check that run out would be by doing this, plus just spin it and just see naturally is it warm? Is it naturally bent? And it may be. If it is, then that's why they tell you in the beginning to check that run out. And we just simply didn't do it the other day. So are you engaged with the function?
Yeah.
In mid stroke, are you in?
I'm in by that far.
Oh, you are? Okay.
I'm in far enough to read that little bit.
So did you zero it? Yeah, you zeroed it, and you're getting about what, about 5? Not even 5. You're getting about 4.5. But what does the book say? I think the book is saying that no more than, well, on radial run out, it's just not even that much. On radial run out, it's less than that. If it's greater than 3,000. So right here it says for shaft run, excessive shaft run out greater than 3,000 adversely affects final alignment. 3,000 is what they're saying here. So whoever's watching the video, they're showing you here in the book. And this is on page 216. Thank you. Page 216. They're saying that if you have an excessive run out with that dial indicator greater than 3,000, it's going to affect your final alignment. And so we've actually got a little more than what they want, a little more than is recommended. So it's having an effect on our alignment a little bit.
Don't you add them together?
You go to the extreme. Look, go to the highest number and then zero it, and then you get your TIR, your total indicator reading from that. You go to your maximum reading and then zero it. So if that was the most extreme position, then you're zeroing the dial. Now the dial is going to give you a true TIR, total indicator reading. It sure did. The 4. I think I seen a negative number. Go back it up again. I think I seen it go negative one time. No. Well, it did. See that? Just a little. You need to zero it now. Zero it again. Now that's it. Now it's going to be about 3 is what it's actually going to be. Actually close to 4, close to 5, and then see does it come back to 0 on the lowest number, and it does. Over 0. You got roughly about 4,000. So this is not what I would call a bad case. It's just real world stuff. It just got a little bit of that to it. On the other side is left. And the other side is perfect. Now shoot it back on this side, and let's see the run out on this. Get a little recording of this. So we're doing a run out check on the driven machine now, which could be your pump. Wish I could get rid of that glare and still see.
Get a little bit closer. It was better if you get a little bit closer, while you see it now. You see it now.
Now. Looks like it went negative that time. Getting that old glare on there. What's that? Make it a little bit closer to you. Man, that's pretty good there. I see a negative there. You see a -1. Or is it my angle error? Is that, am I doing that to myself? Camera maybe? It's negative a little bit. So that's extremely good there. I mean, you're talking 2,000. So on the driven machine, what that means is this shaft is truer than the shaft on the motor or the coupling. Whatever's off of it here, we ran off the coupling. The bore on the coupling could be off a little bit. If you check the shaft itself, you would be able to judge the shaft alone. But now, when you shoot it off of the rim of the coupling, you're looking at the total run out of the coupling and the motor shaft together, which is ultimately what you're stuck with. You know, you really got to get that reading off that rim anyway, because it's going to be a combined error there, which is not a big deal, not a big deal at all. So what I would do would be to try to correct that with your jack bolts till you get it maybe within, say, 3,000. No, that way, or a little closer, and then let it roll. You know? So at this point, and you actually already did. Have you already finished that part there or not? So then you're gonna put the dial back on, right? I mean, not that, but you'll put the clamp back on to try to finish this part right here. So you'll shoot over to you want your 0 at 3 o'clock and then come back to 9. You're back to that 17, that -17 there. Okay, so you can use your jack bolts now and try to make that adjustment, and we can just read that while you're doing it.
You got me, bro? Your back is.
I'm just leaning. I'm leaning to just give it some relief there. Stabilize the camera there.
I'll help you. You want me to?
What it is, if I stand freehanded, it's going to jerk like crazy. If I lean, it's kind of like when you're TIG welding. If you're TIG welding, you brace on something, you can weld straight. If you don't, you can weld crooked. That right there. You got to brace on something.
It gets worse the older you get.
It'll be a bad looking TIG weld if you ain't braced on something. But I had broke that chain out a few days ago. And man, yesterday I couldn't find the darn chain nowhere. I thought I lost it or something. I left it out here at the shop. I come in this morning. So it says +4. Well, you have you'll have to go. Yeah, you're sitting at about a +7 now. So what you're going to have to do now, you're still going to have to go back and get it at 9 o'clock or 3 o'clock to see. Go to your most extreme reading on the horizontal, and then you got to re-zero the meter again. You know? Hold on. Yeah, shoot it back at 3 o'clock again. Let's go to 3 o'clock again. So what's the most extreme reading as far as from here to here? Which one of them is most extreme? Well, that's an up and down thing now. You know, let's do the horizontal. You know what I'm saying? Yeah, that's up and down. That's up and down. You want to do just the horizontal for right now. You're dealing with jack bolts. So you're dealing right now with a positive 43, and that's a more extreme reading than the other one. So I would zero it there. Mercy. This thing's playing mind games with me. There you go. So that's a 0, and that's in the 9 o'clock position there. So now he's going to shoot around the 3 o'clock, and let's see, what does it tell us there?
30. Negative 30.
So it's a negative 30.
Negative 31.
Right. So it's a negative 30 something, and over here was a positive what? Right. You zeroed it out. So it's 0 over here, and over there again, what is it?
31.
It's a negative 30.
Negative 31.
A negative 31. So leave it there and do the adjustment. And split the difference. I would split the difference. Just split the difference there. Don't go the whole route.
15.
I would do half of that. Oh, that's too far. Go back, jack it back the other way 5 more thousandths, or you're going to end up chasing your tail. Right there. Now make sure all 4 of your jack bolts are touching.
Zero it out.
Yeah, you can go ahead and zero it out again. And now you're going to read it back over here at 9 o'clock. See what happens. Look at there. Dead on. Okay. Back over 3 o'clock. Hot to my nose, man. Hey, look. You ain't messing with no average team here. Look, hey, anybody out there looking to hire somebody, any Goodyear supervisors out here looking around, you got your man right here. He'll start out at what, $38 an hour?
Yeah.
About 38. He might come down to 32 like y'all talking about. He'll think about it. He'll think about it, right? Got Patrick over here supervising this whole thing, keeping sanity in this shop.
Oh yeah.
He's keeping us all in line, including trying to make me behave. Okay, because you got a nutty professor here, you know. So okay. So now you can check your vertical. So you're sitting here at you got a plus 22.
You want to try to
Yeah, you want to snug those up, but oh, none of that stuff's tight. Oh my gosh. Oh, that's right. Yeah, exactly. Yeah, of course. Yeah, I'm sorry about that. Yeah, you had to move those. Yeah. And then you want to recheck what you did once you tighten those and make sure that it throw something off.
What about that coming loose when you do it?
Something moved there. I feel that though. Something did move.
You good? I'll let the wrench gave or the bolt gave. You don't want to touch it.
Yeah, something moved. I feel that right there. Feel that right there with your hand.
They done it a while ago. I don't know why.
What you have to do is when you loosen these, you got to loosen them just a teeny tiny amount. Not enough to actually allow. When you move them, in other words, when you move them, you can't loosen them way up where it's gonna throw your readings off. In other words, if you go much, it's gonna throw things off, and your readings are gonna be. See, now all of a sudden it's way different now because of that.
But they ain't tight now.
Right. You gotta listen. You gotta have them. You gotta have them snug. You gotta have them almost tight, but not so that you actually gotta kind of force these to move them, so that you're not dealing with a false reading there.
What's the reading on this side now?
So the reading on this side.
We loosen it.
If you're dealing with a negative 13, I would zero it. Okay, and then you'll bring it back. Mm-hmm. So you're dealing with now a negative 28. Yeah. So look, these bolts have to be not super tight, but they got to be snug, and then you're going to actually have to like big friction drive this thing back with these jack bolts. You can't allow much floating going on, or it's going to be, or it's just going to be running in circles.
That may be 14,
15 or 14.
14.
Mm-hmm. There you go.
Let's see. Go down to 0.
Mm-hmm. Get you back around that way, and then we're going to flip the gauge. And you're sitting at about a -2,
-2.
a -2. What I'd do, I'd go ahead and tighten down all these and just see what happens. Just see what it did to you. Let's see how good that feels right there. Man, that's slicker than the onion right there. Feel that right there. I don't feel no gap on that at all. See there? See there? That makes a difference. So these have to be almost tight, just enough to where you've actually got basically you've got the
It's reading better now.
reading better now, and you got all four of them tight.
2,000, about a 1.5.
Mm-hmm. So now if you zero it again, you zeroed it at 3 o'clock, and it's going to shoot around 9 o'clock. We're going to flip around here. Y'all don't get dizzy out there watching this. And it's at -6.
Mm-hmm.
So what you can do is barely loosen. I mean barely, and then do a little bit of movement there. But you know. There you go. You've already moved it.
Yeah, I'm moving it now.
Yeah. 2. Mm-hmm. You got to stop right there. And then tighten it down, and then we'll just see what the numbers are now. And how about on the other side? All those over there tight too? Going the wrong way. About 6 down, negative, right? Like -6 down, and kind of get your zero back out. Come back this way. And it's a +5. See if you can drive them really without doing much loosening at all. Just see if it'll do a little like with a bearing press. You can slip it, without.
Wrench down, right?
But just don't break the bolts. Look, you got it. Are you backing off the ones over here?
I'm backing off. I didn't back it off.
You have to do that part. You definitely have to do that part.
Keep it.
We're going to end up breaking the bolt in 2 like that. You have to loosen it enough to where it'll move a little bit.
Probably
Oh,
gonna move.
listen up.
Probably gonna move whenever you lose the one.
Mm-hmm. what you have to do is just do a prescribed move and then retighten and then look at it again.
It went bolt. Bolt went.
The bolt broke. Okay, so we get the bolt out. Isn't that something? That's we should do that.
It's close to me.
Let's just do that. Actually, it's closer now.
Yeah, it's close.
So you're at a +2, and what else? Okay, so look, yeah, 0 it now. Right. That's fine. You're within 2 now. You're within 2 thousandths now. So are these, how snug are these? And that feels nice and smooth right there. It does. That feels nice and smooth right there. You got about roughly about a 2, 3, about 3 maybe. Okay. Come back. That's really good. That's nice. We're gonna stop there. Okay. We're gonna stop right there, and we'll turn it on and run it because this will be our last session for this. Yeah. Now look, did we loosen these so that when we tighten these, it'll actually move?
Loosen it when we tightened it, but we made us unloosen it again. We didn't unloosen it.
You did not unloosen them. Yeah, you want to loosen those so that it'll float and that you're not going to put anything in the bind. And I got some T handles if you want to use them. The T handles are.
T handles right there, but these are.
Okay. Whatever you prefer to use. And you might want to move the fixture out of your way too. But the dial indicator is something that you may not particularly need to use it on something as small as this is per se. They may not require that, but on really big installations, on super big motors, they're going to require a bare minimum of dial indicator, and in some cases they're going to do laser. But a lot of places don't have the laser, so the dial is a very cheap way of doing it, and it's active, you know. So it's probably going to be most popular to do it this way if you've got something critical. He's loosened these step screws so that that coupling can float toward that, and you're not going to bind anything. It's just going to draw it together and close that gap in. The one thing we did not do is we did not do a dial indicator reading off of the face of the couplings. We did the rims, but not the faces. They get into that in the book, and that's for checking for angular misalignment that you may have to end up going in there and putting more shim at the back than in the front and doing angular. We didn't get into that. We're running out of time on it, and actually, what they've done is very, very nice. It feels good. It feels very, very good, and they've done very good there for what we have here. And, all that's nice and tight, and all your footing is tight. All your jack bolts and stuff tight. And so if you want to know the final fix on this when it's giving you a problem, you tighten it till you break a bolt and then you stop. Okay, you see that right there? What this is, I'm going to pull your leg here. This is a calibrated torque bolt. So when you turn that and you get to the right exact torque, it snaps. And then that means you have a perfect reading right here. Ain't that right, Darren? Exactly. So this is a special. If you've never heard of one, it's a torque bolt. Okay. I'm pulling your leg out there.
Sure, I'm give you this so you'll remember me.
Okay. So Luke is giving me the broke bolt head there to remember him. Y'all remember Luke here. This dude, he doesn't know his own strength. Got some strong dudes in here. So now let's turn this thing on and see it run. And we'll wrap up the it actually goes back in the bottom of that box there. Yeah, in that gray box that's in the bottom here. Sure did. So all this here is nice and tight. Everything's nice and tight. If you notice here, we got a lockout device here that we kept that thing locked out. This is extremely important. So you can, they got lockout devices for pretty much anything you can think of, and that's a lifesaver. I can tell you from experience, that finger right there got busted in 5 places. You can see where it's the leftovers from it over not using lockout. I hate to confess that, but this is a lot of years ago, and again, I was working on the machine. I was in too big of a hurry, and you know, we all think, I ain't got time to lock this thing out. But if you ain't got time to lock it out, guess what? You may end up out of work a while over injury. So take it from me, lock it out, please. There you go. So here, that's a nice smooth run right there. Running as smooth as a Singer sewing machine. I like it. So you don't have a lot of excessive vibration on that. Do you hear it? Do you feel that? That's actually, I think that's quite good. Don't you think so? For a rigid coupling, that's darn good. So I'd give that an A+ right there. Yep. So the rigids are used in places where they don't allow any flex whatsoever. So some applications they have to have that. But as you know in the book, there's all kind of other ones that have elastomeric elements in there that has some flex to it. So that's probably the smoothest I've ever heard that thing run, to tell you the truth. I've heard them bucking way worse, you know. That's actually quite good. So I'm impressed.
It's only because of that jack bolt.
Just remember, when you go to buy bolts, you get the torque bolts that snap. And when it snaps, then you're done. You're done. Okay? And if you didn't understand what we just said there, then you call this fellow right here. I'm not going to disclose his name on YouTube, but you see him there, right? You see him? Okay, that's very good. Now, one thing that they do have in the industry is called a laser alignment, and we're almost out of time here. I'm just going to show you what it looks like. And I sent y'all a link on Viberline has a set of videos. If you go to viberline.com, they got a set of videos that shows you what we just did with the straight edge, with the feeder gauge, the dial indicator, and then they get into the laser. So this thing here's got a laser thing on it, and it's got you plug in these 2 lasers here. It's got the cables that plug in. It's got bubble levels. It's got lasers and all this stuff, and this stuff gets clamped on. There's 2 of them, and so they both get clamped on. One to the movable and one to the fixed like that, and you got to get the laser tuned into each other with the eyes like that, and it's a little longer process to go through. But if you're interested in this, and if where you're working at, if they have these, this is the company here. It's called a Shaft Hog. So you can go on the Viberline.com and see videos on how to set these up. And basically, in a nutshell, what you do is once you get them on there, you line the lasers up. You go through, and I emailed y'all the steps on this thing. Basically, what you do, you go through, and you give the Shaft Hog some data, and the data that you give it, that you program in, first of all, they tell you, we got about 5 minutes. They tell you to mount the laser to the shafts and connect the sensor cable to the display unit to this thing. Aim the lasers into the detectors. You have to get them aligned. You got the lights have to be, everything has to be lined up with the lights. Then you got to wait 5 minutes for the lasers to warm up to get most reliable results. So that's your preliminaries. And then your steps would be, I took pictures of all this and emailed to y'all. These pictures of everything in here. So they tell you to do a pre-alignment check on run out. What a dial indicator. They're telling you to use a dial indicator to check that run out, that radial, that axial run out like we did. They also tell you to use the straight edge. It's preliminary with the feeder gauge. So that's all recommended prior to doing this rough alignment prior to using this. You check it for soft foot. You did that, okay? And again, I took pictures of all this stuff. And then you torque your bolts and torque sequence. And then you check, do a final soft foot check. So in the beginning, their initial soft foot check is actually checking it with all the bolts loose. And they're checking for soft foot and they correct it with all the bolts loose. Their final soft foot, after they torque all the bolts in, is they loosen one bolt at a time and check soft foot again. That's their second soft foot check, which is Bible line and very, very well known. And then once you cure soft foot for the second time, then you mount the shaft onto the shafts. You align the sensor till you get the proper light that we turn on here on the display until they both of them show on the lines and everything's lined up and you get a proper light showing up there. You have to level the sensor. There's some wheels here that you can use to move these. You loosen these and you can move them. You move the lasers like this up and down and with these wheels and lock them in. So when you get them to where all the lights agree and you're lined up, then you go to the next step. I wish we had time for that right now, but we're just running out of time. It's actually about 2 minutes. And but if you got one of these or some other brands, and that Bible Line's got a newer one out now, newer than this one. So the video that's out there is on a newer model than Shaft Talk. It's got a different name to it. It's got a bigger screen. And then, so once you get the lasers lined up, you rotate the sensor to the 12 o'clock position. And you go to, and then you enter the dimensions of the distance between these rods here, the rods. So wherever you have them mounted, that you got to tell the display that dimension. And then you hit the right arrow. And then it asks for a dimension that goes from the laser shaft on the right side to the foot, the first bolt on the motor. You give a dimension from that laser to the foot of the motor, the front foot. You measure that in inches and you actually punch that in. And then you hit the right arrow key, and then you punch in the final dimension of the center distance between the mounting bolts on the motor. Give it that dimension. You program that in. And then you move the laser to those 3 different positions. Once you move it to the next position, you have to enter and let it see the position of the lasers at that point. And you give them in 3 different positions like that, and key in where it is. So at the 9 o'clock position, when you get it to the 9 o'clock position and the display reads correct, then you will enter. You press the right arrow to register that measurement. And then you rotate the sensor to 3 o'clock and you use the right arrow to register the measurement. And then from that point, you can rotate back to 12 o'clock. And what it's going to do is it's going to give you numbers here. It's going to give you numbers on the screen, and the F1 and the F2 represents, the F1 number represents the front feet, the F2 number represents the back feet. And what you would be shooting for would be the minimum number closest to zero. It's telling you that you're either plus 7.8 thousandths or plus 9.7 thousandths from ideal. And you have to try to seek towards zero. Correct. The correct vertical line, make sure that you're at 12 o'clock. You record these numbers. Now look, that says 7.8 mil and 9.7. The positive values you have to, it's high, you got to remove shims. See that? So if it's high in the positive number, you got to take shims out and drop it some. You're shooting for actually zero is what you're shooting for on the number. If you're negative, then you have to, let's see. At the 12 o'clock position, you're dealing with shims up and down, right? Shims. When you shoot over to the 3 o'clock position, you're talking about the jackpot, right? So if you're negative, say on your 3 o'clock reading, it says for negative values, the machine that is towards you, you've got to adjust it away from you. And you shoot for zero on those horizontal readings. So if the laser is at 3 o'clock, you're dealing with horizontal movement. You got to move it. If you got at 12 o'clock, you're dealing with shims. And ideally, with the laser numbers, you're trying to shoot for zero. Is ideal. You get as close as you can to that. So it will take a lot of playing around with it. It'll probably take longer with this than what you just did. I think the dial is actually going to be faster than this. But in some cases, you have to have that because it's required. If it's a big old several hundred horsepower motor that's high risk of damage if it's not perfect, then the company will probably, what I've heard of is some companies don't even let their guys in the plant do the alignment on something major, like if they buy an air compressor, they'll have the vendor come in and do it. Because it's actually, there's a liability there. If you buy a compressor and they don't do the alignment, then they're not going to be responsible for something that goes wrong. So I know a guy that goes around doing stuff like that. Danny, something he used to be, he travels all over the East Coast doing that kind of stuff, air compressor. But anyway, so that kind of gives the gist of it. You may or may not have a laser set up where you go to work at. If not, that dial indicator, you can't go wrong with that. That's really gets you, as you can tell, that's a nice smooth run right there. I mean, I would be happy with that, seriously. And these fixtures are cheap. You know, they don't, you're not talking much money at all to have this. Not much money at all. This come out of the kit. It's, the kit is right here. It's Peterson alignment set, and it's got rods of different lengths there. So if you need longer length on your stick act, you can have that. And there's other pieces here that come with it. So that's the inside of the kit there that come out of. And it's Peterson's one company. There's a lot of that have stuff, you know, Bible line. So that will kind of give you an idea. Hopefully give you a good start on doing alignment. So anyway, thank the guys here for a great job. I had to give them a hand, you know. Awesome. Actually, quite an awesome job there. So, but guess what? We're going to save getting the bolt out for another class that I'll probably save that for volleyball group because volleyball will be coming for other stuff. And I'll say, hey, we got a broke boat. We got to get this thing here running. We'll lose the $5,000 an hour. We got to hurry up. You know. Okay, so that's it for the regular. This is our last regular class period. Next week, the 17th and the 19th, you guys will have a break from here. So, Brandon, everybody, my recommendation would be go in Moodle. But this weekend, I'm going to finish grading everything. So next week you can go in, even as the weekend goes, you can go in and go back to your worksheets and hit the right side of the screen, hit review, and you can hit print and print it to a PDF file on your device. It can be printed on a computer, on a file instead of on paper. Choose a PDF print, give it a name, and then save it. At least save it on your device, and I would recommend printing on paper and study. Have a paper record of that stuff. If something goes wrong with your phone, then you've lost all your stuff. You know? So that's what I would do. and then you got the exam will be written straight from the worksheet. It's going to be about a roughly even number off each worksheet. And I may include some pictures of some stuff that we've done and ask you some questions about. It'll be everything that we've done. Mostly worksheets and a little bit of picture from out here maybe. But it'll be, the exam will be not next Tuesday, but the following, the 24th at 9 o'clock. You come over to the classroom here, and someone's going to take you to a computer lab. And my guess is it's probably going to be one of them labs right over here in this hall, I'm guessing. But it could be some other room. You'll have a regular sized computer instead of being stuck with them little Chromebooks. And anyway, so by that time, I should be home. And I'm going to be monitoring from home what's going on with the exams to see, make sure everybody's in. And if you got any problems whatsoever, there's going to be a proctor in here to help you with the computers. And but I'll still be available at that point. I should be home by next weekend in recovery. So that following week, I'm going to be watching close, and I'll be available to help y'all by phone. So if you get a snag on something, call me. I'll be working at home anyway, get ready for January classes for motor controls and stuff. I got some new stuff I'm going to be studying for that. So, but do y'all have any comments about the class? Anything? Do y'all feel like you picked up maybe a few things this semester? A few things that can help you. I hope so. Yeah, yeah. We can always improve on it. If you got suggestions on how we can make it better, shoot me an email. Or text or anything like that, or either just tell me directly, hey, I would like to see something done different. But what I've done this year is I've on purpose haven't done much in the book. It's what maybe someone else would have done. We stayed in the lab almost every day because the classes are so short, and I felt like it was just going to be not a rip off, but kind of cheating if we didn't. You know, so that was my gut feeling. I'm kind of glad we did it that way. So anyway, but thanks again. And hey,
we like to give Mr. Durwood a hand for being one of the greatest instructors we have. He's really passionate about his work. I'd just like to thank him.
Thank you very much.
Much luck on you.
Yeah. Thank you very much. Thank you very much. All right. Thank you very much. These guys have been awesome. I've really enjoyed it. I really have. Sure have. Thank you. Now, God bless all of you. Thank you. Keep coming out here. And finish your education up, you know, you can. Because all of you got the sky's the limit on what you can do. It really is. The sky's the limit. You can keep going. Get all the education you can, and you'll be glad. It's going to pay you back. The dividends are going to pay you back like good interest in the bank. Every minute you spend in here is going to be like money in the bank later on, so it's going to keep paying you back. It's going to put you in a higher level starting out, like so over good years, you're just saying they start selling below 30s over there. That's not happening anymore. That kind of money's not over here, but it is over Fayetteville. And so, and again, they wanted you to have the degree to be able to get in and do that, right? You got to have that degree. Right. So I'm happy for you. I really am. When you get through with all this, stay in contact, come back, kind of tell us how it's going. But you can be an inspiration to somebody else that's struggling going through this. It's what can be done. I like to have students come back, give testimony on what they're doing, and if they can share, maybe even share what they're making possibly, or at least what they're doing. And then it's going to make somebody else want to strive and say, you know, if he did it, he come from here, you know, maybe I can too, you know. It'll give somebody a reason to try, a reason to keep going, a reason to do it. And not to give up in the middle of it. Because there is a reward out there. If you work hard, the reward's coming. It really is. So anyway, thank y'all. And I'm going to close this thing out, and we're going to tell y'all for a happy Thanksgiving ahead of time. This ain't close to it, but this is actually, we won't be in. Hope y'all whoever's watching this, have a good Thanksgiving and a Merry Christmas. And we'll see you back on YouTube early in the year for I'll be teaching hydraulics and pneumatics and motor controls and electrical maintenance. So thanks, guys. Yeah. We're going to stop the video now. Yeah. Yeah, if we can put up, anything that, we can put, yeah, thank you, appreciate that. We'll be in contact. Brandon, you're just getting in and we're just finishing, man. Brandon,
Yes, sir.
we have just finished, buddy.
Oh, okay.
Yep, but I've been recording. I'm going to upload it to YouTube, okay?
Okay.
I'll be on Zoom also for ELC 111 at 12 o'clock.
Okay.
Unless you finished everything. I don't know if you finished everything.
I'm not sure. I'll go through and check it here in a minute.
As of last night, I think there was a little bit of stuff that might have been on 9 or something other you were still working on, I think.
Yeah.
Those other boxes, can we get them in there too? Yeah. If you can, if you got a minute. If not, I got some. I'm going to upload, I'm going to hit the start button in a minute, and it'll process, and then I'll have it uploaded later on.
Uh-huh.
This chart does not give you
That's what you gave us at ELC 111, right?
right. Go back to that column. Go back to the lowest temperature column, and whatever the amp says on the motor, you're going to have to go over, and that would be the minimum 5 line. But you want to actually add it. If it says, if that motor says 10 amps, multiply it by 1.25, boost it to say 12 and a half amps, and then come in here and pick a wire size that'll work. You got to give it 25% of what the name tag says for thick motor, thick wire side. And then on the breaker side, you could also do that same thing, give another 25% minimum before you take the breaker side. But that breaker's got to be bigger, a little bit bigger than that peak that you come up with. But shoot a picture of the nameplate when you get to it, and I'll help you come up with a final decision on that.
I got this. You give it to us,
Yeah.
I got the question. So if you're getting your breakers 240, that's what's coming in, and you want to run it out to like a light switch, how do you switch over?
How did you switch 240?
Yeah, like when it's coming in breaker at 240, when it leaves the breaker, you want to go to just a regular light switch. A little electrical element, something, how do you switch over?
How did you switch 240 volt motor that way?
No, not the motor. Like the main breaker box. It's coming in here, it's 240.
Yeah.
And when you leave that 240, you want to go to like just a regular light switch, a regular plug or something. Like that hook your computer into. That makes sense?
Yes. And once you do, you go to, I got the receptacle on my own need to use that.
Look, no, look, I see you tonight. All right.
Yes, sir. I'll see you next year.
Okay. Thank you. Okay, I've been zooming around here, so whoever's watching, thank you for watching. This is Durwood King with Sampson Community College, and it's been a great semester. We've had some very hardworking students. They've learned a lot, and we've I think we've had some nice labs in here, and covered quite a bit in the book. As much as we could in the book. We got the main meat and potatoes. I'd say that we got the best cuts we could out of the book without putting too much time in there and sacrificing lab time. So thank y'all for watching. God bless you, and have a nice Thanksgiving and Christmas. And we'll be First of the year, I'm going to be doing hydraulics and pneumatics. There may be some of that on Zoom possibly, and motors and controls. There may be some on there, depending on the ratio of shot time versus class time. There'll probably be some Zoom portion on everything I'm doing in January as well. Maybe not as much because we're getting more shot time now than we had been. We're allowed to do more shot time, which is great. It's pleasant. So I'm gonna go ahead and stop it. You can contact me at dking@sampsoncc.edu with any questions, and if you want to enroll, if anybody's watching that is not enrolled at the college, I'd be glad to have you come out and register and get you in some good programs out here. We've got industrial systems technology that covers the electrical, mechanical, hydraulic, pneumatic, machine shop, welding, refrigeration. All that's bundled in a multi-craft type degree. Plus, you can get the electrical certificate. You can get a full 2-year electrical degree now. We have a new degree that includes the industrial, the electrical classes I teach on motor controls, PLCs, so forth. It's also got residential wiring. It's got some commercial wiring, some solar field type classes in there, and National Electric Code. That degree has got a lot of things in there that's a very wide range on electrical that you can go into several different fields if you want to. And we have the HVAC program if you're interested in heating and air. Got welding degree if you like welding. We have we got ag. We got a lot of stuff. So whatever you like, we've probably got something for you in the occupational division here. So contact us and we'll try to match you up with something that you're suited for and that you're gifted for. Everybody is born with something they can do, and we just need to find out what it is. Everybody's naturally inclined to do something well, and it's just a matter of trying to find your niche kind of wherever that is. Not so easy to find sometimes, and sometimes you have to try different things before you really find it. And that say, well, hey, I think this is it, because I think I'm kind of naturally pretty good at this, but whatever it is. So thanks again. I'm going to end the session, and y'all have a blessed holiday, and thanks for watching. God bless you.